Hello everyone, it's Wilson here. Today I want to talk about this integral here. So as you can see, this integrand is the square root of 25 minus x squared. By just looking at it, it feels like it's a trig sub problem. But don't forget that there are limits right here. This is a definite integral. So that means we can probably just interpret it geometrically so that we do not really need to do the integration, right? We don't even need to use Fundamental Theorem of Calculus. We don't even need to find the antiderivative. We only need to just interpret it as an area, right? So how do we do that? First, we look at the integrand, and the integrand, as you can see, it's y equals the square root of 25 minus x squared. So now if you look at this equation here, what kind of graph do we get from this equation? We can square both sides. Okay, so if we square both sides, we are going to get y squared is equal to 25 minus x squared. And then if you move this negative x squared to the left side, then you are going to be getting x squared plus y squared is equal to 25. So as you can see, this is actually a circle. Okay, so this is actually a circle with radius 5, right? With radius is equal to 5, and its center is at the origin. And center at the origin, right? 0, 0. But you know that we are actually not going to draw the full circle. The reason is that we are not having this equation. We are actually having this function right here. This is the square root of 25 minus x squared. Actually, I should say positive square root of 25 minus x squared. That's really just saying that we only want to graph the top portion of the circle. Okay, the radius is the same, the center is the same, but we only want to draw the top portion of the circle. And so how do we draw that? It's actually quite easy, right? We just count 5 units from the center. The center is at the origin. So 1, 2, 3, 4, and 5, right? We start right here with this point, and then we go in the other direction, 1, 2, 3, 4, and 5. So it's right here. So we get the other point, and then also we go up 5 units. 1, 2, 3, 4, 5. We have this point here, and then you draw the circle. Okay, so I'm just sketching right here. So it will not be perfect, but then we just want the shape and we just want the idea, then it will be okay. So now we actually have a region that's bounded by the semicircle here and also the x-axis. And so our goal here, okay, our goal here is to find the area that's bounded by the semicircle, this shaded region, right? And the x-axis. So that's bounded by the semicircle and the x-axis, and we want to find this area. And this is really just a half disk. And how do you find the area for a half disk? So you just use the area formula for a circle, and then you multiply by 1/2, right? The reason for why we go from -5 to 5, as you can see, it's just based on the limit. So we get -5 right here, and then that's the other number. This one is just 5. Okay, so now how do we find the area? So the integral, right? So the area of the half disk. Area of the half disk is going to be what, 1/2, and then pi times the radius square. Okay, so now what is that radius? The radius, as you can see, the radius is going to be 5, as you can see here. That's the center. This is the circumference, right? This point is on the circumference of the circle. So now the radius is 5. And so now we just put the 5 in here. Okay, so we have 1/2 and then times pi and then times 5 square. And so if you do the calculation here, you get 25/2 and then times pi. And then, so that's it. That's the value for this integral here, right? We didn't do trig sub. We didn't use fundamental theorem of calculus. We didn't even find the antiderivative. We just interpret that as a region, and then we find the area of the region. That will give us the area for this integral. Okay, so that's it for this problem. To help me make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video. I will see you next time.